Hello friends, now I am going to discuss using a limits to calculate the derivatives. So we have already learned how to use a partial derivatives. So if you are not a friendly, so you need to understand means watch my previous video. So let's see uh, so 1 minute. So if you want to see whether a limit comes into a player calculating like a derivative, so if you are feeling a good about the what we learned so far, so if you are still digesting, maybe considered coming back to this sidebar later. So let's see, the simply allows us to do the some interesting explorations about maths. So take our functions, like just we have already taken a previous functions. It's like a same. So just previous I have taken functions like this. It's a fx limits to calculate the limits. It's a name of this topic is the limit to calculate derivatives. So let's see, just if I write here, the fx should be equal to the x square, and now we approximate the slope for x will equal to 2, drawing a line close to neighbor point like a 2.001 by adding steps like 0.0001. So let's see, if we use a limit forever that decrease the steps like s, what slopes is approaches. So if I want to write here limit s tends to 0, and so x plus s should be equal minus x square. It's a x plus s and minus x. This means the limit to forever, this means it's a limit to forever decrease that step s, and we can describe it this way. So let's see the example, like we can see the example. It's an example like we are interested to the slope where x will equal to 2, and so we can write the limit s tends to 0, and we can write 2 plus s should be equal to square minus 2 square, and it's a 2 plus s and minus 2. So your answer should be like a 2a plus b whole square. Yeah, you can also a square minus b square, so it's a cancel it, so it becomes, and now it becomes like a 4. It's 2 to cancel s, so 4s by s is s cancelled. It's a, so forever the approaching the step size is the s tends to 0 but never reaching it. Remember, so we cannot touch point x will equal to 2. Now let's see the how do we write in a simply. So let's see here, try. I am going to, let's say, using a limits to calculate a slope. So using limits to calculate a slope. It's a slope. So first we create like a x and a step size like a s. So x comma s will equal to its symbols like a x comma s. It's a inside like a syntax. And now the declarer functions f should be equal to x square. Now we will create like a substitute into the range over functions. So it's a slope underscore f, slope underscore f, it's equal to f dot sub parenthesis x and x plus s, and it's a minus, it's a function like a f, and it should be divided, whole must be divided by like a, it's a parenthesis. Again you can put here the parenthesis and x plus s, and it's a minus x. So we have created slope. Now we are going to the substitute the value of the 2 here. So let's see, slope underscore 2, it's a slope underscore, it's a slope underscore f dot subs and x comma 2. So we are putting a value like a 2. So it's a slope, yes, slope, it's not, it's a slope, right? And I will see here like output calculate the slope at the x will equal to 2. So it's a results. Let's see here the result. It's a result should be equal to limit slope, it's a slope underscore 2 comma s comma, it's a 0, and print result, print so we have gotten like a output 4. So now if you do not assign like a specific value of the x and leave it alone, so what happens, we decrease our step size s infinitely towards 0. So this is a way we can easily calculate this value. So I hope we will understand like enhance of the fs. I can also change like a results limit and slope underscore, we can take a f and s comma 0. It's a, we have gotten the result. So let's give the our derivatives functions. So simply was the smart enough figure out. So simply was is a never. So let our step size reaches a 0 and but forever the approach 0. So this convert like fx will equal to x square reaches its derivative counterpart like a 2x. So after that we try to understand like what is the chain rule. It's a chain rule when we build a neural network, so we are going to need a special math trick called a chain rule. So when we compose the neural network layer, we will have to untangle the derivative from each layer. But for now let's just learn the chain rule with a simple algebraic way. So let's see the one example like this. So let's go on my whiteboard. it's a like this. It's a I am taking the two variable, two functions. One is it's a y will equal to, if I write the one function, it's a chain rule. It's a rule. So let's see. Just if you write here, if I write here, y should be equal to x square plus 1 and z should be equal to y cube minus 2. So let's learn the chain rule with a simple algebraic example. So notice that these two functions are linked because the y is the output variable in the first function but in the input variable in the second function. This means we can substitute the first function's y in the second function z like this. So let's see, just I am putting the second functions, like should I write here like z, your new equation should be like x square plus 1 whole cube and minus 1. So what is the derivative of the z with respect to the x? So we have substitute this value and we can dz upon it's a x. So let's see, it's a this is the substitution methods, and just after substitutions how do let's see the finding the derivatives z with respect to the x. Let's try this simply. And so let's see the our derivatives look like here, like dz. It's how do we are differentiating, so dz by dx, it's a x, it should be like x square plus 1 whole cube minus 2 here. So derivative for the z with respect to the x, and we will get an output like 3 times 2, it's a 6x, and it's a x square plus it's a 1 whole square. But look at this, let's start the over to take the different approach. So if we take the derivatives of y and z functions separately and multiplying them together, this also produces the derivative of the z with respect to the x. So let's see here. It's we are going to, I am going to the differentiate here like with respect to the x. So dy, it's a dx like this, x square plus 1. So should I write here like a 2x, and similarly z I am going to write here like a dz by dy, it should be like a y cube minus 2, it should be right here 3y square. So what happened if I multiplied like this, dy by dx, and now divided by, so it becomes like a dy by dx, and it's a dz by dy. So it's a cancel, it's and here we can also 2x should be multiplied with the 3y squared, it becomes like a dz by dx will equal to 6x, it's a y square. I think it's clear. So let's see, how do, so now we see and we got the same derivative functions here. So but how do solve this this algorithm without algorithms like a simply. So let's try here. Let's go and try it. It's first we need to write here. It's a function like this. It's a from a simply we have already imported. So let's create the one variable. Z should be equal to, inside of this parenthesis, x square plus 1, so plus 1, and after that should be like a square cube and minus 2. Just we have already created. Well, now we want to the dz and x, so we are differentiating like a dz with respect to the like a dx. It should be equal to differentiate should def and zx. So it's a z comma x. So differentiating z with respect to the x. Now print your print and write dz underscore it's a dx. So let's see, it's the output we have gotten like this. Just we did discuss with you. So our derivative it's look like a 6x x inside of this parenthesis like a x square plus 1 whole square. So I hope it's this concept is should be a clue, and now you are comfortable to solve this type of the way. But one is the other way we can also use like a chain rule. So calculate the derivative like a dz by dx without the chain rule, but still getting the same answers. Let's see here the integrations like the opposite of the derivatives and integrals, so which find the area under the curve for a given range, and we will find the area under probability distributions. Although we will not use the integration directly, and instead will use the cumulative density functions that already integrated. It's a good to be aware of how integral functions find the area under the curve. So let's see, just I want to take an intuitive approach for learning integrals called like a Riemann sums. It's a very important for the AI and data scientist. So one let's see the sum and one data flexible and to any continuous functions. Like first let's point out the finding the area for the range under a straight line. It's easy. Let's say I have a functions like a 2x, and I want to find the area under the line between like a 0 to 1. So it's my approach like here. And how do we plot here? So it's a part of the integral. So let's see, it's a functions, and I will try to describe these areas. So let's go and whiteboard, and then I will try to discuss these things. So let's write the integrations. So let's see here. Where is my whiteboard? It's right. first we need to erase all these values here. It's good. Okay, let's see. Just I am going to discuss integrals. So it's a integrals. Integrals. It's the opposite of derivatives. So I have take like a functions of the f(x) will equal to, it's a 2x, and first the finding the area of the range under this straight line, it's a easy. So I want to find the area under the line, and it's a find the area under the line between 0 and 1. It's a 0 and 1. So let's calculating this area. So like suppose you have this type of the diagram, and it's look like this, and then this one, it's a shaded area like a 1. So how to calculate like a area of this portion? So I am finding the area bounded between the line and the x-axis, and in the range like a 0 to 1. It's a 0 to 1. So the basic geometrical formula, the area of the triangle, just you can say here area will equal to half into base into height. It's a base equal to, it's a 1, it's a base, and it's a height like a 2. So 1 by 2 into it's a base into 2, it becomes like a 1 unit. It's a 1 unit. So our area should be like a calculate like a 1 unit. So it's a easy. And similarly find the area of the x square, like if I write here, find the area of the, if we write the functions like this, x square plus 1. So it's a similar way, and the area should be area between like a 0 and 1. So let's see here how do we calculate this area with the algorithms. It's the most important, and I try to find the integral approach in a Python. So let's see. First we need to go here. It's the integral approach. So let's see. It's an integral approach here. So first we will create a def functions. So def approximate like an integral. Def approximate proxy APPROXIMATE and create integral. So INTEGRAL, and we give the some parameters like this. It's a is the one parameter, the B is the another, it's a N is the third, and now let's create just a F as a functions. And it's a delta like a DELTA, it's a tail delta underscore X should be equal to, it should be equal to like a B minus A, and it will divide by like a N, and total sum should be like a 0. It's a total underscore sum should be equal to 0. Now let's create the second we are using like a for loop for I in range. It's a range 1 comma n, so plus 1 midpoint. So midpoint should be equal to 0.5, and it's a parenthesis like a 2, so a delta underscore x 2 I minus 1. Total sum like a total sum it's a like your function should be like a total sum and f as a function, and now write here midpoint. Now we want to create the another functions like a def my functions. Go back, we will start from like a def, it's my underscore, it's a function, and we should write here the x and return we have written like a it's x square plus 1, so plus 1. And now I want to get area, so let's see the what will be the area. Let's go back. Area should be approximate, just a will p, it's an approximate under score integral, and we will start from like a should be equal to the 0, b should be equal to the 1, it's a range, and n should be equal to like a 5, and f should be equal to like a my functions. So just I have written here my underscore, f should be my, it's a my functions. It's clear. So just I have written just area. Now I want to the print here area. It's a print area. Let's see here. So it has been created like this, but I have gotten something like something mistakes here. So print area is so I am not getting an exact value. So where did I get the some mistake left there? Let's check it. So it's a def approximate integrals like a, b, and f, and delt delta underscore x b minus a divided by the n, and total sum should be like a 0. I don't think. Now for loop we will start from like a total for I in a range liquid 1 and 1 plus 1, and midpoint point will start from 0.5 star to star e plus delta underscore x. It's a delta underscore x and underscore x and 2 star I minus 1. It should be closed. Total underscore sum should be here like a total sum and plus function. It's a f should be midpoint. I think it's clear. And now I am going to sum and okay, I didn't write the return functions here, so return total. It's yeah, let's see here. Return should be like a return. It's a total. It's a return total sum and like a delta delta underscore x. So delta, and let's see here. Now I have gotten like a output here. So it's a 1.33. So we get at the area 1.3. So what happened if we use like a 1000 rectangles, and let's try out like a we can also do. So it's a approximate. So if you I want to write here like a it's a my functions, it's the same, and I want to change like this. So it's a possible to get a output here. It's like here Control C, and if I want to take like 1000 rectangles in hands of the n, so it's a what happened. So we are getting the some more precisions here and getting the some more decimal place. So what about the millions of the rectangles? It's possible. So like this. So it's I think we are getting a diminishing the return here, the converging on the value 1.33. So 0.33 parts forever the recurring. So if we are the rational numbers like a 4 upon 3, so we can write 1.333 and recurring. So as we increase the number of rectangles, the approximations starts to reach its limit, a smaller and smaller decimal. So it's a these are the basic performance of the integration. So let's do and try to solve more questions and do the more practice. It's the basic way, just I try to understand. So thank you very much. It's a I hope it's we can understand. I am Manibhushan. Thank you.